All right, let's dive right in. Today, we're cracking open the C++ toolkit. We're going to look at two legendary features that give programmers absolute raw control over a computer's performance: pointers and functions.
But first, let me ask you something. You ever stop and think about how something huge, like a modern game engine, or even your computer's operating system, runs so ridiculously fast and efficiently?
Well, the secret is, they're not just running on the computer. They're practically woven into its DNA. They get direct access to the most fundamental resource there is, the computer's memory. We're talking no middlemen, no safety nets, just pure, unadulterated speed.
And the language that hands developers this incredible power is C++. So today, let's open up that C++ toolkit and see exactly how all this is even possible.
Okay, our very first tool is probably the most famous, or maybe infamous feature in C++, the pointer. You know, the best way to think about a pointer is as your own personal map to the computer's memory. It lets you go exactly where you need to.
Now, here's the textbook definition, and this is really key. A pointer is just a variable, but its job is to hold the address of another variable. See the difference? It doesn't hold the data itself, just the location of the data.
To make this super simple, let's use an analogy. A regular variable, say an integer, is like a house. The data, the number 10, for example, that lives inside. A pointer? It's not the house. Nope, it's just a piece of paper with the address of that house written on it. It just tells you where to find everything.
And to actually work with these addresses, C++ gives us two super important operators. First, there's the address of operator. That's the ampersand. You use it to ask, hey, where does this variable live? Then there's the dereference operator, the asterisk. It does the exact opposite. It says, okay, I've got this address, now go there and tell me what's inside.
So, great, we have a way to find memory addresses. But why does that matter so much? Let's jump into our next section and see how this becomes one of the most efficient ways to handle data, period.
Pointers are really the key to unlocking some serious high-performance tricks. They are absolutely critical for whipping through huge arrays with incredible speed, and they're essential for managing what we call dynamically allocated memory. That's just a fancy way of saying a program asks the OS for a new chunk of memory while it's up and running. Now, the reason pointers and arrays are such a perfect couple really comes down to how your computer organizes memory. When you make an array, the computer lines up all of its elements right next to each other, in one nice continuous block. No caps, nothing in between.
And because all that data is laid out so neatly, C++ lets you do this cool thing called pointer arithmetic. So if you have a pointer aimed at the first item in an array, you don't have to do some complicated math to find the next one. You literally just add 1 to the pointer and poof, it automatically jumps to the very next element. It's an insanely fast way to cycle through massive amounts of data.
Okay, let's set our first tool, the pointer, down for just a second, and grab the next one from our toolkit, functions. If pointers are all about controlling where the data is, well, functions are all about controlling what happens to it.
At their heart, functions are really all about organization. They let you take a big, messy problem and chop it up into smaller, neat, self-contained blocks of code. So instead of writing the same logic over and over again, you just write it once inside a function and you can call it whenever you want. And this isn't just about being tidy. It's about making your code way more reliable and easier to test. Functions can even do some pretty advanced stuff, like recursion. That's where a function actually calls itself to solve a problem. Look at this factorial example. The function keeps calling itself with a slightly smaller piece of the problem until it hits a simple endpoint. Then all the results just cascade back up to give you the final answer. Pretty cool, right? And now it's time for the main event. We've looked at pointers for controlling memory and functions for controlling logic. But the real magic of C++ happens when you put them together. This is the master technique.
So let's set up a new problem. Imagine you've got a variable in one corner of your program and you pass it over to a function. How can that function possibly make a permanent change to your original variable?
The whole secret is in how you hand over that data. The default way, called call by value, is like sending a photocopy of your data to the function. The function can scribble all over that copy, but your original, totally safe, completely untouched. But with call by reference, you don't send a copy. Oh no, you send the actual address of the data. You send a pointer.
And here it is, the aha moment. When you pass a pointer into a function, you're not just giving it some information. You're handing it the literal key to the house.
The function can now use that address to go directly to your original data and change it for real.
And that right there, that's the beautiful synthesis of our two tools. It's the ultimate combination of pinpoint memory control, all thanks to pointers, and clean, organized logic, all thanks to functions.
So let's just recap our C++ power couple real quick. Pointers give you control over where the data lives in memory. Functions give you control over what happens to that data. It's that 1-2 punch that makes them so incredibly powerful.
And let's bring this full circle, back to our very first question. This direct, down-to-the-metal control over memory and logic, that is precisely why C++ is the language you use when you need to build the world's highest performance software.
When you absolutely have to squeeze out every last drop of performance. I'm talking rendering mind-blowing graphics in a game engine, managing a whole operating system, executing financial trades in microseconds, or running massive scientific simulations, this is the toolkit you reach for.
So we've seen where C++ gets its power: direct memory control from pointers and structured logic from functions. This combination gives programmers just incredible speed and control. And that leaves us with one final, big question to think about. When you're given that much power, what kind of responsibility comes along for the ride?